Chemistry involves energy as well as matter, and so we need to be familiar with the different types of energy. There's two basic categories: potential energy, kinetic energy. Potential is stored energy, so it comes from position or composition. Kinetic energy, kinetic, what does that make you think of? Moving, right? Kinesiology is the study of movement, right? Kinetic means movement. So kinetic energy is the energy of motion. And energy can be converted from one type to another. If we have a boulder at the top of a hill, it has potential energy. Because if you were able to push it so that it could go down the hill, it would gain a lot of kinetic energy, right? It would start out rolling slowly, and it would roll faster and faster and faster. There's a picture coming up, but it's not necessarily the picture I want. So here's the boulder, and here's the hill. So up here, it has the most potential energy. As it gets closer and closer to the center of the Earth, its potential energy decreases, but it's moving faster and faster, and so its kinetic energy increases. The potential energy gets transferred into the kinetic energy. Any questions about that? Here's an illustration from your book, and these are the same illustrations that are in Dr. Umber's slides. So we think about shooting a cannonball. It goes up, and it's slowing down as it goes up, so its kinetic energy is going down as it comes up, but its potential energy is going up, because potential energy is the distance above the ground. The farther above the ground, the more potential energy it has. So it gets to a certain height, and then it starts coming back down. As it starts to come down, the potential energy decreases, but the kinetic energy increases. Personally, I like the swing. Wrong piece of playground equipment. Okay, so let's think, there we go. Let's think about the swing. Okay, and so here we've got the swing. It's a really, really sad swing here. We got a little stabilizing crossbar there. So you know how swings work. You swing up, and you swing down, and you go back up the other side, right? When you come up at the peak, you stop, right? Just for a fraction of a second while you're changing direction. That's where your kinetic energy is at a minimum, but your potential energy is at a maximum because you're the highest above the ground you're going to get. Then the potential energy turns back into kinetic energy as you swing down. When you reach the bottom of that path, you're going as fast as you will, and then your kinetic energy is a maximum. You come back up the other side, your kinetic energy is being turned back into potential energy. So the next time you have an opportunity to swing, you think to yourself, ooh, I'm changing potential energy into kinetic energy, back and forth. I don't know, maybe that'll take the fun out of it for you. Sorry. Okay, so this is related to physical states of matter. All substances have kinetic energy. So this bench here, does it look like it's moving? I've never seen it move. It's pretty stationary. It's in the same place every time I come in this room. But the atoms and molecules in this bench are actually moving. But they're not moving as a group in one direction, they're vibrating. So I missed out on telling you about states of matter, but you are students, and students have 3 states of matter. You are currently in the solid state for students, meaning you're fixed relative to each other, you're relatively close together. But all of you are moving. At least I think everybody's at least breathing, right? Some people are fidgeting, chewing on the pencils. Some people might be taking notes. That would be awesome. But you're moving a little bit, right? So even molecules in a solid are moving a little bit. And when we increase the temperature, when we heat something up, the particles move more. So all particles, all substances have kinetic energy. Solids have the lowest kinetic energy. The particles are just kind of vibrating in place. Gases have the most kinetic energy because their particles are just zinging along till they run into something. And so they're really moving and they have more kinetic energy. Liquids are in between. As you increase the temperature, the kinetic energy increases. Any questions? Illustration of 3 states of matter. Here's a solid, close together. These are fixed relative to each other, just like you guys are right now. You're not moving relative to each other. 10 minutes ago, you were sitting to the left of the same person you're sitting to the left of right now. That's what a solid does. A liquid would be like, we're going to have a little break, and you'll get up and walk around the room. We're still close together, but now you're moving relative to each other. That's what a liquid does. Gases have a great deal of distance between them. That's like when class is over, you go out the door, you're going to go all different directions, completely independent of each other. That's the gas state for students.